Okay, so the first question that I got wrong in the test was write the equation of the line passing through the points 2, -3, and -4, 9. So now that I know how to do it, I'm going to explain it to you. So first what we got to know is what is the equation of the line? This is y equals mx plus b, seen here. M being the slope and b being the y-intercept. So what we want to do first is find the slope, or otherwise known as m. The formula for that is y2 minus y1 over x2 minus x1. So after that, we have to see like what's going to be x1 and what's going to be y1. So x1 and y1 are going to be the x's and the y's of the first order pair, and x2 and y2 will be the x and y of the second order pair, logically. So as we substitute this in, we see m equals 9 plus 3 over -4 minus 2. This ends up being m equals 12 over -6 and finishes up in m equals -2. There we get y equals -2x plus b. But there's a problem still. We don't have this. We don't have b, the y-intercept. So what do we do to get the y-intercept? So what we do is we get one of the ordered pairs we got. I'm going to use the one -4, 9. So then we just have to plug in and solve for b. Y equals mx plus b. 9 equals -2 times -4 plus b. B equals 9 minus -2 times -4, and that ends up being b equals 1. This in the end gives us this answer in the bottom, y equals -2x plus 1. That is the final answer. Okay, now that I learned how to do it by correcting my previous error in the test, um, uh, here I set up a new problem, a quick problem that is really similar to it. So we got write the equation of the line passing through the points 4, 9, and 7, 18. So as in the other on the other time, we need to remember what's the slope of the line. That is y equals mx plus b. So what we want to do first is find m, which is the slope. Again, we go m equals, this is a formula for the slope, y2 minus y1 over x2 minus x1. So let's substitute in the numbers. M equals y2, which is 18, minus y1, which is 9, over 7, which is x2, and x1, which is 4. So we continue doing the math. M equals 9 over 3. M equals 3. So what we got here is y equals 3x plus b. But again, like the other time, we're missing the special b. We want to find that. So what we do again is we go back, we find one of the ordered pairs, and we just plug it into the formula. So y equals mx plus b. I'm going to use the ordered pair 4 and 9. So 9 equals 3 times 4 plus b. 3 times 4 is 12, plus b equals 9, minus 12, that is -3, equals b. So then, of that, we substitute that into the original formula with the 3 we found for the slope, and that will equal y equals 3x plus 3. And that is our final answer. Okay, so Another question that I got wrong in the test is find the zeros of each function. So I have to find the zeros of the function of which is h of x equals 3 of x squared minus x minus 2. So now that I know how to do this, I'm going to explain this. First of all, we have to find what is a, what is b, and what is c. A in this formula is 3. B is -1. And C, finally, is a -2. Putting the arrows to C. Okay, so what we want to do first is now write the quadratic formula down, as written down here. X equals -b plus or minus square root of b squared minus 4ac all over 2a. So then we follow up with substituting a, b, and c into the respective places in the formula. We end up having x equals 1 plus or minus square root of 25 over 6. So this means that we're going to get two answers instead of one. So we got two zeros. So first you have to explore the possibility of 1 plus square root of 25 over 6. The square root of 25 is 5 plus 6 plus 1 equals 6. So that means 6 over 6, which equals 1. x1, our first zero, equals 1. So then we have to do it instead, but now with the minus. I have to explore that possibility. So x equals 1 minus square root of 25 over 6 here. So square root of 25 again is 5. 1 minus 5 is -4. -4 over 6 is equal to -2/3. X equals -2/3. That means that x2 equals -2/3. So basically the two zeros in our function are x1 equals 1 and x2 equals -2 over 3. Those are our zeros, otherwise known as our final solutions. So now I'll be doing a similar problem to the last one I did with zeros. Here I'm going to find the zeros for the function h of x equals 5x squared minus x minus 5. So what we first do, we put it alone. 5x squared minus x minus 5 equals 0. We identify like the last time, a is equals 5, b equals -1, and c equals -5. After that, we again write the most important formula, the quadratic equation. X equals -b plus or minus square root of b squared minus 4ac all over 2a. After that, we substitute each one, a, b, and c, into respective areas. We do the math, and we arrive with x equals 1 plus or minus square root of 101 over 10. This means that we're going to get two zeros instead of one. So first we got x equals 1 plus square root of 101 over 10. So what we do here is we write 1 over 10 plus 1 over 10 square root of the 101. That's x1 right there. For the x2, we got 1 minus square root of 101 over 10. So we do here the same thing. 1 over 10 minus 1 over 10 square root of 101. That is x2 right there. This. So we got the two solutions for this function are x1, which is 1 over 10 plus 1 over 10 square root of 101, and then there is x2, which is 1 over 10 minus 1 over 10 square root of 101. These are zeros, otherwise known as our solution, and also known as the final answer.